The James Webb Space Telescope, JWST, one of the most advanced instruments ever created for space observation, has recently uncovered possible indicators of artificial activity on a planet located far beyond Earth. This remarkable discovery moves us closer to addressing one of the most enduring and profound questions in human history. Are we truly alone in the universe? For millennia, civilizations across the globe have pondered the possibility of other life forms in the cosmos. From ancient mythologies to modern science fiction, the idea of life beyond Earth has captivated the human imagination, giving rise to countless literary works, philosophical theories, and scientific endeavors. This enduring curiosity seems woven into our very nature. Humanity has always sought meaning and connection, often projecting these desires onto the stars. We search, not only for distant civilizations, but for answers to who we are and where we belong in the grand cosmic scale. Our fascination with the universe is not just about the potential for alien life, but also a reflection of our need for companionship, understanding, and purpose. No matter where it comes from, even if it originates from intelligent life light years away. Back in 2021, before JWST's full capabilities were operational, scientists posed an intriguing theoretical question. Could we one day detect artificial light on distant exoplanets, such as Proxima b? This planet, orbiting the red dwarf star Proxima Centauri, the closest star to our Sun, is located approximately 4.25 light-years from Earth. It lies within the so-called habitable zone, a region where conditions may be just right for liquid water to exist. Proxima b is believed to be in synchronous rotation with its star, meaning one hemisphere of the planet always faces the star while the other remains in permanent darkness. This led researchers to hypothesize that a technologically advanced civilization could use solar panels on the day side to generate energy, then transfer it to the night side to maintain habitable conditions. In a published paper co-authored by astrophysicist Manasvi Lingam, scientists outlined how vast arrays of solar panels could theoretically be detected by telescopes with sufficient sensitivity. If an alien civilization existed and employed such technology, the reflectivity of the panels, or even emitted light from powered infrastructure, could serve as evidence of their presence. Fast forward to 2024, and the James Webb Space Telescope, with its unprecedented range of sensitivity and resolution, may have begun detecting such elusive signals. Unlike any telescope before it, JWST can observe in the infrared spectrum with extraordinary precision, allowing it to identify minute details that would otherwise be lost in the cosmic background. With this technology, humanity is now capable of scanning exoplanets like Proxima b, not just for natural characteristics, but for potential signs of artificial light or heat distribution, subtle hints that might point toward alien technology or life. Before diving deeper into the implications of such a discovery, it's important to recognize the scientific leap that made it possible. JWST represents decades of planning, collaboration, and innovation. It was launched to expand our understanding of the universe by answering some of the most fundamental questions. How did the first galaxies form? How do stars and planets come into being? What are the origins of life? Its core mission includes searching for the faint light of the earliest stars and galaxies, observing the evolution of galaxies over time, and investigating planetary systems both near and far. Proxima Centauri b, often referred to simply as Proxima b, is a compelling subject for such investigation. It is classified as a super-Earth, a type of exoplanet that is more massive than Earth but lighter than Neptune or Uranus. These planets offer a unique glimpse into planetary formation and the potential for habitability. Proxima b orbits its star at an incredibly close distance of about 0.04856 astronomical units, completing a full revolution in just 11.2 Earth days. Its mass is approximately 1.07 times that of Earth, suggesting that it may have a rocky surface like our own planet. Despite being so close to its star, Proxima b receives much less energy than Earth does from the Sun. This is because Proxima Centauri is a red dwarf, a class of star that is both cooler and significantly dimmer than our Sun. In fact, Proxima Centauri's total luminosity is only about 0.16% of the Sun's, and in the visible spectrum, it emits a mere 0.056%. Over 70% of its energy is released as infrared radiation. These factors make Proxima b an intriguing candidate for further study, particularly with instruments like JWST, which are designed to observe in the infrared. The scientific interest in exoplanets has grown dramatically over the past few decades. Although possible evidence for exoplanets dates back to 1917, it wasn't until 1992 that the first confirmed detection of an exoplanet orbiting a pulsar sent ripples through the astronomical community. Since then, the number of confirmed exoplanets has exploded. As of April 1, 2024, a total of 5,653 exoplanets had been discovered in 4,461 planetary systems, with 196 of these systems hosting multiple planets. Many of these discoveries are associated with M-type stars like Proxima Centauri, which are common throughout the Milky Way, but difficult to observe due to their faint brightness. What makes Proxima b especially fascinating is its proximity to Earth. At just 4.2 light-years away, it is the closest known exoplanet that might support life. It belongs to the Alpha Centauri star system, a triple star system that includes Alpha Centauri A, Alpha Centauri b, and Proxima Centauri. This makes it not only scientifically interesting, but also one of the most accessible targets for future interstellar exploration, whether by robotic probes or someday even crewed missions. Its relatively short distance on a cosmic scale makes it a practical and strategic focus for current and future astronomical efforts. The James Webb Space Telescope is uniquely equipped to push the boundaries of what we know about such exoplanets. Its advanced optics and deep space observational capabilities allow it to search for biosignatures and technosignatures, signs of biological activity or intelligent life. Among JWST's core objectives is the investigation of planetary atmospheres for gases like oxygen, methane, and carbon dioxide in unusual concentrations, which might indicate life. Equally intriguing is the possibility of detecting artificial light or thermal patterns that could point to alien infrastructure or energy use. The search for extraterrestrial intelligence, SETI, is a natural extension of this pursuit. SETI represents humanity's collective effort to listen for signals from intelligent life across the galaxy, using massive radio telescopes and data analysis tools. Rather than searching for material treasure, the SETI project envisions a kind of cosmic scavenger hunt, seeking whispers of civilizations through the noise of the universe, whether in the form of radio signals, laser pulses, or patterns of artificial light. Humanity stands at a critical juncture. For the first time in history, we have the technology not only to gaze into the depths of the universe, but to potentially recognize other intelligent life that may be doing the same. Instruments like the James Webb Space Telescope mark a new era of discovery, an age where science, imagination, and exploration converge. The discovery of Proxima b and the possibility of artificial activity there may someday be viewed as the spark that ignited a new chapter in our understanding of life in the cosmos. As we continue to explore, it is essential to keep asking big questions. What will we do if we find life? What does it mean for our philosophies, religions, and view of ourselves? Are we prepared, not just technologically but emotionally and socially, for such a revelation? The answers may redefine what it means to be human. Thank you for exploring this journey with us. If you found this fascinating, don't forget to like, subscribe, and turn on the notification bell so you don't miss future updates on our search for life beyond Earth.